3, 2, 1, live. Thank you for joining us. My name is Gregory. I work with the Singula team and I do developer relations here, despite being a Ruby software developer. We at Singula team are outsource and outstaff. We hire developers, teach developers, and contract them to our clients. In order to do so, we need to maintain a high level of expertise. And for this, we do different activities, including these online meetups. These online meetups are kind of special. We are doing them not to promote ourselves, not to make money, not to teach people something. We are doing them in order to provide for our fellow software developers a place where we can talk to each other, discuss interesting things, talk about Ruby software development, how to do it the right way, how to write better code, maintainable code, readable code. So our talks, they are not some educational material. They are hot topics that should be discussed, and they will be discussed on these meetups. Our meetups are organized like this. In a few minutes, I will start first talk. They are pre-recorded in studio with great quality, video, sound, slides. But the speaker, he will be with us in our chat, and they will read your questions, answer with text, and after each talk concludes, the speaker will join us live, and with me and with you, they will discuss the talk topics, and we will make ourselves a better software developer. So please subscribe, like. This provides more people to our meetups, more interesting questions, and more topics to discuss. And now we will start with the first topic, where Nikita will tell a story about how services talk to each other with message queue.
Message queue. How services talk. Hi, I'm Nikita Bogomolov and I'm software engineer in Evron company. I experienced in backend more than 7 years and for now work mostly on the Ruby language, and examples in my lecture will be also on Ruby. If you want to discuss something or ask questions, you can contact me in my social networks, Telegram preferred. I'm friendly and open to new people. So let's start from question, why queues? Why you need to know about it? The most powerful thing of queues, this is async interaction between your distributed services. Second thing is delivery guarantee. All your data will absolutely deliver it to consumer. Handling at least once. This is also about delivery and quality of delivery. Message log. We can store all communication history in database and open it when we need it. And my favorite feature, we don't think about consumers, we just send messages into the space and hope that somebody will receive it. What software we can use for it? They called message brokers, and there are not only two solutions, but I will tell the most popular, Kafka and RabbitMQ. Kafka was created to work with big data, and Kafka works with batch messages with delay. So when you're receiving your batches, you have delay. Kafka waiting until the batch will be ready for receiving. Rabbit was created to work with small, fast events to notify your services about something that happens in your system. So it's fast and furious, it hasn't store. In Ruby for Kafka we have a low-level API gem Ruby Kafka, and based on it frameworks Waterdrop, Phobos and Karafka. For Rabbit we have kind of monopoly. It's low-level API IMQP and IMQ protocol gems and a bunny client. It's official client with good documentation. So Karafka and Phobos also have a good documentation and powerful functionality. Let's go to code. These 3 examples about Kafka sending messages. First is using Ruby Kafka. It's pretty simple. We just create the client and deliver message hi to topic greetings. Second and third do the same, but using the producer instance. Here, how we send messages through Bunny. We need to create connection, we need to start it, we need to create channel, define the queue, and publish message hi to this queue. Also, we don't forget to close connection. This is how we consume messages in Kafka, using Ruby Kafka, the simplest example. So we just iterate all messages in topic greetings, and we can handle it inside the block. With Bunny, we again have to create channel, define the queue, and subscribe to this queue for receiving messages one by one. Okay, cool. Now we know how to send and receive messages. Let's split monolith into microservices. But not so simple. Give me a chance to tell you more about some difficulties. Broker doesn't responsible for processing only delivery. As you see, method deliver message in Karafka returns nil. That means that your producer doesn't know anything about result of handling, only delivery. Next important thing, impossibility of exactly one's delivery. This paradox, also known as two generals problem, and describes how it works in the real world. For better experience, brokers have acknowledged mechanisms. Consumers send to broker the delivery confirmation, and broker wouldn't send copies of messages. The important thing that your consumer worker can fail anytime, in the beginning, in the middle, or in the end of handling messages. One of solutions to prevent data inconsistency is idempotent code. This is example of non-idempotent code. If we will receive two same messages with user attributes, we will create it twice, or not create, or get active record not unique error. So this is bad for us. We make inconsistency in our database. Another example, we use find or create by method, and there are no problem to receive 1, 2, 3 or 10 the same messages. It creates user only once, and next time it don't make inconsistency in your database. Okay, let's talk about deployment, how we can deploy our brokers and use it on our server. First of all, you need main container, broker, Kafka or Rabbit. It's a black box, and you can deploy it and use it in the simplest way. Second thing, it's producers and consumers. Through monitoring, we can upscale our consumers. For example, if we see many messages stuck in queue, we can upscale some consumers and quickly handle it. But this is headache of DevOps, not yours. If you're interested in details, I can recommend you this book. So what a developer headache? First of all, it's always a business logic. We should work with it the same way we work through HTTP. This is our main thing to do. All these are same things. Sometimes it could be really tricky and confusing. Interesting thing is a schema registry. It's kind of API contracts and describe how messages should look like. Explore it in more detail. You can see my favorite example of message structure. We have event name, we have created a timestamp. The popular instruments for schemas and serialization your messages is JSON schema, Apache Aura, and Google Protobuf. This is Aura, and it looks pretty same as a JSON, and we have also a converter from JSON to Aura schemas. This could be very useful. This is example of Google protocol buffers. And why we need schema? Schema registry lives on separate server with access from producers and consumers instances. Your code can download the schema, validate the message before sending or before receiving. And if you need to update your schema and version of your code, you need to do these steps. First of all, you need to upload new version of schema to your registry. Now it has two versions, version 1 and version 2 of schema of your message. After that, you can update consumers. It should consume old and new message versions. So it could be two consumers or one with if-else clause. After that, we can update producers and produce message only version 2. And after that, we can disable old consumer, remove this code, and fully pass to version 2. And the last step, we can disable all consumer, remove old code, and use only version 2. Remember that producers doesn't receive any result from consumer, but we need it. How to solve it? I had a real example on my previous project, new user creation process. We need to create user, send it to profile service, and after creation, trigger another logic. To solve it, we can use pattern reply to. In documentation of RabbitMQ, you can find a full implementation for Bunny, so I wouldn't talk about it. I will tell you how to do it in Kafka. Remember our greeting message. Let's apply new schema knowledge on it. Mark event name with a sync flag, just for clearance. In a producer, we set reply to topic in the meta object. After handling, consumer can respond in this topic with some data. That's all what I want to tell you in this lecture. Thank you very much, and let's summarize. Async communication more complex, but it provides many ways to write your applications. Kafka and Rabbit are different, and choosing one of them, it's a very important architecture decision. Thank you very much for listening. Let's stay in touch. Ask your question in comments or write me in social media. Thank you.
Nikita, welcome to the
Hi,
real
hi
world
everyone.
from our offline recording facilities. And let's talk a bit about messages, async communication, and everything microservices. First of all, let's start with queue applicability. Techniques that you talked about, are they limited only to microservice architecture, or can they be used in our glorious Ruby monoliths?
Yeah, thank you for the good question, Grigory. Of course, no, not only for microservices. The message queues is very useful to realize patterns like event bus, for example. Yeah, in your monolith, you can create the event bus using Kafka easily. You can send the messages from monolith and receive it also in monolith. And through Kafka, manage some different things of your architecture. For example, one part of code that don't know anything about another part of code, you can communicate between them through Kafka, and it's very useful. It's a good way to split logic of your architecture, split your architecture, actually.
Mm-hmm. Give me 1 second, please. Got it. Next, with messages, it's some new mindset, this asynchronous mindset. And as a software developer, I know that sometimes it's hard for new software developers to grasp this async mindset, and they have lots of difficulties. So our next question will be this. From your experience creating microservices and using queues for their communication and working with other developers. These other developers, what are their main challenges, main issues? How exactly do they struggle with queues? So what can we recommend to some developers who are new to this queue business? What are some obvious pitfalls for them to avoid?
Mhm. Thank you. That's a kind of complex question, and the answer will be also complex. So it always depends on project, uh, and it's always choose of your team. So inside your team, you need to discuss how to what first of all what to use for communication. It could be Kafka, it could be Rabbit, it could be more easy thing like dry events, for example. It's also about messaging. And first of all, you need to discuss what to use, and after that, you need to discuss how to use it. And the funny story from my experience, sometimes it could be very deep to queues, and don't forget to simple operations. Use the simple ways. Don't use messages everywhere just because you have it. Yeah.
Yep. During my time as a software developer, I saw lots of microservices systems that scale to hundreds microservices of different type, and I noticed that if you have lots of microservices and they all communicate via messages and queues, it's an entire new mm, kind breed of problems that arises. The problem in question is that for developers, it's hard to understand how hundreds of microservices talk to each other. Even if you can read the source code and read all messages and check your queues, if you have literally thousands of different messages, it will be hard to understand and to grasp what is happening. So, from your personal opinion and observation, how many microservices, queues, and messages are okay? What should be a number where developers should worry about them and start to use some advanced techniques, call the architect, and prepare for worst? So what is the safe number of microservices, queues, and messages that it's comfortable for us
Mhm.
to handle?
Uh, Thank you. Uh, as you asked about my experience, so I think there is no safe number. So it depends on your provider. I mean, Kafka or Rabbit, and they have really good architecture, so they can manage so many services. I think nobody can write so many services how Kafka and Rabbit can manage. That's why no safe number, but of course, again, it depends on your project. If you need many services, if you have, I don't know, very large business and so many processes, of course, you need the microservices count as your processes. So it not related to broker. It's related to your business and to your business logic. Yeah.
Mhm. Thank you. Thank you. With our traditional approach with one monolith and database, we have a handy abstraction for database access called transactions.
Mhm.
And with these abstractions, we can guarantee that if we want to add multiple changes, multiple related changes to our database, they will all land or none of them land. With queues, it's a little bit different. So if we have a number of steps to be performed by different microservices, or if we have microservices that should perform some task after each other, but we have only message queues to communicate, and these message queues, they are not 100% reliable. If we have Kafka or if we have Rabbit, physical machine that runs them, it can restart, it can hang, and other bad things can happen, so messages are lost. What do you think about the reliability of our solutions, and should we do something about that? Should we somehow handle situation if Kafka is restarted and messages are lost in the middle of that transaction, or such cases are very rare and we should not bother about them?
Mm-hmm. Yeah, this is the good question, and I think it's like senior level question. Um, yeah, the simple answer is you have to forget about database transactions when you are using message queues. So it's impossible to use transaction if you use two different databases. Not the simple answer. Uh, you have to create it by yourself. For example, if you don't know, no, another example. You send the message and another service read it, but you understand that you need rollback it as a transaction. This way, you have to write on the consuming service, you have to write another producer that will roll back your action, roll back your action. Yeah. So when you use messages and queues, you have to forget about database transactions and you have write this logic by yourself. Yeah, that's
That's pretty hard. Lots
yeah,
of messages, lots of states, some saga patterns, and
that's
yeah,
another.
microservices are hard. But let's talk a little bit more about messages and message queues. When we are doing our pet projects or small scale applications, these queues, they look like something endless. We can post hundreds or even thousands of messages, and our receiver, it can pause for some time, even restart, and nothing bad will happen. But in real world, on the some heavy load, there can be millions of messages, and even with some good hardware, message queue can't hold them forever. Like, okay, Kafka can hold a few millions, even billions of messages in its intermediate buffer. But if you add more messages and add them faster when you consume them, after some time, everything will overflow, and we will start receiving errors, out of space errors, or unable to post message errors, and so on. But this internal message queue state, it's not very transparent. Our
Mhm.
system can work for minutes, for hours, and we will not know that messages are processed slower when they are added to our system. And only after some time, our system will collapse under the load of a huge pool of unprocessed messages. From your opinion, what are the best ways to monitor such message queues to be sure that everything is fine and messages are handled faster than they arrive to our queue?
Mhm. Mhm. Thank you for the question. I have two answers. One is the legal answer, and the second like a life hack. So the first one, for monitoring, you have used to, for example, Grafana, Kafka, and Rabbit, and another brokers. They have the API that collect like how many messages in queues, how many memory used, and anything else. You can manage it. You can look at this at Grafana, for example, and also your DevOps can look at Grafana. And after that, you can scale consumers, scale producers. What do you want? And make analyze and make it better. Yeah, and the second answer is a life hack. I used to do this because it's useful. So you have to create your messages not so big. That's not for Kafka. It's mostly for regular events like RabbitMQ provides. So you create the small events and send it to your service. And on your service side, consumer side, you not collecting not the big message, you collecting the small message and launch some processes inside your service. So the messages are really fast, and the work of your service could be slow, but you also could I forget the word. What we do through monitoring, scale your consuming service usual way, like you do it before. So that's the life hack.
Nice. 15 minutes. Okay, one more question. With queues and messages and how to offer craft these messages, I personally know about two software development sects. The first sect, they tell us that all the information should be put inside the message. Like all the data required should be there. They should be stateless. No external entities are required. So it's fire and forget. The second sect at opposite, they say that putting everything into messages makes them very big and handy and produce problems with load for our application. So the second sect, they insist that most of the data should be stored in the database, and messages, they should only reference such data with IDs or any other means. So what do you think? Should we put all the data into messages? Should we put only data identifiers into messages? Or should we somehow creatively combine these approaches?
Yeah. Also, as I explained in previous question, we have a life hack for small messages. That's a good approach. But yeah, you're right. We have two ways, or three ways. Okay, the big messages, the small messages, and the medium. So again, it depends on your project and how you create your architecture. What can I recommend for it? For big messages, Kafka will work very good because Kafka ready to work with big messages. And somebody used Kafka as the database also. So this is useful. For small events, the RabbitMQ is much better because it works fast and good in this way. But through Kafka, you can use small messages, and through Rabbit, you also can send big messages. But also you can create your application this way, that you send only IDs, as you said, and for example, get information from the database, from shared database, I don't know, from another API. So how you create it, you will use it this way. I suppose that it could be used big messages, and one day you understand that is so big, you can rewrite it as we like. So rewrite and send only IDs and get data from database or another API or another service.
Nikita, thank you a lot. I'm looking forward to see you as a guest on more our meetups. And if you have some more interesting topics with meetups.singula.team, we have this offer talk button, and you are welcome. Bye bye, Nikita.
Thank you.
And we are moving to our next talk. But before, please subscribe, like, so this translation is demonstrated to more software developers who can come here, ask their question, and provide us an interesting perspective about Ruby development. And our next talk from Artyom will explain distroless images without an operating system for our Docker container, and how they are used in a modern Ruby development.
Hi all, my name is Artem Slomatin. I work at Samarkand Tech as a software developer. Now I want to discuss with you about distroless images and why we need them. Today we look how we at Samarkand Tech prepare Docker images and how we use it. And after that we discuss what distroless images are and why we need them. After that we look how we prepare distroless images and examine our integration results. Firstly, we use a classic approach for Docker images. So developer creates a branch, push some code into it. After that, CI/CD pipeline builds an image of the application from this branch. And after that, CI/CD pipeline pushes this image into our image repository. After that, developer change Helm charts, and CI/CD pipeline comes in. After that, Argo CD sync up changes and applies them to the relevant environment. Note that we do not use cloud solutions. Our Kubernetes runs on bare metal that we rent. So what's problem occurred? First problem is the Docker image size. Main problem is that their size ranges between 5,000 to 9,000 megabytes on average. And secondly, security issues, because our Docker image contains necessary utilities that we do not use, but hackers can't exploit them. So it's a security issue. We come to distroless concept. Distroless images, unlike a classic one, contains only the minimum to run the application, no unnecessary utilities. Moreover, that we do not have unnecessary programs, their images are less in size than classic one. Distroless images can be built with appropriate tools like Bazel, or can be taken from pre-built one from Google, for example. So, how we start? Firstly, we need a pre-built image that taken, for example, from Google, or can build someone by our hands with Bazel tool. And we need the second Docker images, classic one, which has distro. After that, we install unnecessary dependencies into classic one. And as second step, we move with multi-stage building, we move these dependencies into the distroless one. And so that's it. Distroless images prepare for our application. Enough with theory, let's go on to practice. We have an Elixir application which represents user notification subscriptions. And we have official Elixir image, like classic. Original size of this image is 445 megabytes, and we use Bazel for distress image building. And so for stress testing, we take two endpoints of the application. First one returns the user notification subscriptions. Second one modifies them. We change load in steps. For first endpoint, for every 4 minutes we add 300 RPS, and for the second one, every 4 minutes we add 30 RPS. The total load time is 12 minutes. Let's look at the graph. Image that uses distress images have slightly improved performance by a few %. More interesting that distress image consumed a little less memory than classic one. So what's about size? As I told before, original size was 445 megabytes. In our distress implementation, final size was 76 megabytes, which is 6 times lighter than classic one. So the main disadvantages of distress images is that you need some time and resources to transit and test out your results. Second one, developers need some tools for debugging, but distress does not have anyone. And you manage container internals, which cause some problems because you have to manage it. Anyway, there are a few advantages that we have more control over container size, over container internals. In container, there are no unnecessary utilities that can be used by hackers. And sometimes you can get slightly performance boost. I want to extend my gratitude to my colleagues Alexey Maximov and Roman Smirnov for their valuable contribution to this research. I am Artem Solomatin from Samekotech. Thank you for your attention.
Artyom, welcome to the present, and thank you for your talk. Let's check our audio. Please say something.
Hi, everyone.
Nice, I can hear you and hope that our viewers can also hear us. So let's talk a little bit about distress images. From my third attempt, I am able to pronounce it correctly. Still lots of training to do. And let's start from the developer point of view. As a developer who develops some Ruby or Elixir code that should be deployed with Docker, I want to test it on my laptop before pushing my changes. And in order to test it, I do not only start Docker containers from images, I also want to connect to these containers with debug protocols, with SSH, to do some experiments, to debug, profile my code, to check if everything is working as expected. And with distress containers, it's tricky because they lack our tools. There is no bash, there is no git inside. There is no ping to change network. We do not have literally anything within such containers. So while using such containers, how are your developers do routine development tasks on them?
So there are two approach as I can recommend. First one, you can create a second distress image, but with debug instruments like SSH, mind TTA, because without it you can't connect to Docker, Bash, and some other things. And after image build, you can use it in your development environment. Other approach is take not destroys images, classic one, and use it for development for your development purposes. So yeah, without our developing instruments, it can hurt hurt much for developers.
Which approach do you prefer? Which approach do you recommend for some developers who want to start using or testing distress images?
Hmm. I think using a classic approach is better for development experience because you don't need to mind about TTA, Bash, some other utilities that you need like curl or widget. So you just take classic one and run in your development stuff. That's all.
Got it. Our next topic for discussion is more about deployment. You mentioned that distress images are much smaller. And yes, they are, for your particular example, they are less than 100 megabytes, while a typical image with some operating system is around 500 megabytes. So that's 6 times the difference. But modern deployment systems, they do not download images and layers each time you deploy. Normally, they use some container registry and some local cache. So, for a particular physical server with some virtual machines that run your workload, or with some Kubernetes nodes that run your workload, any image, any layer for Docker image will be downloaded only once. And after your developers push the next version of the 500 megabytes Docker image, only the difference will be downloaded during the deployment. So this 6 times less initial download, how important is it in the real world scenarios?
Image size, it's not the main goal of destroys images.
Mhm.
Main goal is security issues because
Mhm.
we run our security checks on production images. In Elixir app, it's about 400 security issues that Docker can scan. And it's only Docker. There may be more of that. After we move to destroys images and run a Docker scan, we face around 12 or about
Mhm.
this number of security issues, which much better than old one. Uh, and
Yeah.
uh,
Yeah.
and after that, you can have a little performance boost and as I say, a size reducing, but it's minor improvements about that.
Yes, such drop in reported issues is some magnificent 2 orders of magnitude, which is really great. And please tell me, what kind of security issues are they? Is it something related to the application itself being insecure and doing something bad inside the container? Or are there some ports open and something that makes the container vulnerable to other container, or vulnerable while some ports are exposed to the balancer and open internet? What kind of security issues are there?
So main security issues is that environment in which container run. It's like widget, curl, SSH, apt and other utilities that can be used by hackers to exploit container issues. So when you remove them, you reduce hacker abilities to attack container. So, but when you move to destroy these images, your application can contain security issues because programmers do errors in their code, and this thing cannot fix by moving to destroys images. So destroys image is about environment issues in which our application run, not about application itself. Like that.
Got it. Great. Really interesting. My next discussion point, you mentioned Elixir programming language, which is like Ruby, but not Ruby. So why do you use Elixir, and what the amount of an Elixir you use within your company? How much Ruby development do you have, and can you compare it with an amount of Elixir development you have? So how is Ruby and Elixir are balanced within your company?
So about Ruby development, we have about 50 Ruby developers around, and Elixir command is reduced to about 2 times. So we not much in Elixir, but we have some applications which under some load, and for challenging that, we used Elixir about like about notifications for users. We have a lot of notification to send to you for sending to user, and in Ruby monolith, it's not a good way for this kind of thing.
That's actually quite a fresh approach. Normally, we use Roda or some other frameworks and machinery to handle heavy load with Ruby, Falcon, for example, with async fibers or something like that. I can see that in recent years, while we have a general Ruby programming language renaissance, we also have some Elixir popularity growth. So, if this fits your talk, why do you like Elixir as a company, and why do you use Elixir and most probably famous Phoenix framework to do such kind of services instead of, for example, using Roda or using Go programming language or Rust or some other hyped microservice technology?
Yeah, it's interesting question because for Ruby programmer is kind of normal grading over next level to moving to or Elixir or Go language when you facing some performance problems and other things. But in Elixir, what main thing in Elixir is that it's looks like Ruby, but it's not
Yep.
Ruby. It's so not Ruby. But syntax is very similar. And yeah, what a great thing about Elixir is that about its tooling. For example, Mix tool for working with project, and Phoenix framework that creates a very tolerant to load applications without having deep knowledge about concurrency and other things that programmers think when he writes code in Go language or Java or something like that. Yeah.
I hope to bring some crystal developers to our podcast, to our meetups, not podcast. It's very important to distinguish them to really heat up the discussion. Thank you a lot. That was interesting and rewarding. See you later as a guest of our meetups. And if you have more interesting topics at meetups.singula.team, we have this propose talk button that you and everyone who watch us is free to use. You will contact me. We will discuss your proposed talk, and most probably this talk will land up in one of our future meetups. Thank you,
Sure.
Artyom.
Thank you.
And now our third talk, but before jumping into it, please like, follow, subscribe so more people come here, and it's not only me, a person who asks questions. It's much more interesting when Rubyists from other companies join and ignite the discussion, providing different point of views. Of course, I write code for more than 25 years now, and I can support a discussion with our guests, but it's much, much better if more people join. So our third talk for today, Alexander will talk about Ruby versus Go programming language. This is the talk that will be challenging, interesting, and curious to discuss. Let's welcome Alexander.
Hi guys, I'm Alex Illustratov. I'm a senior software developer at a company Gaming with an experience around 8 years, and exactly in Ruby around 5 years, now around 5 years, and in the Golang around 1 year. So I want to tell you a speech about Golang from Ruby's side. Here you can see a plan, and while you're seeing the plan, I'm going to talk to you about how the idea of this speech came to me. Once upon a time, me and my colleagues discussed about Golang. What is it, Golang? How it goes? How about microservices? How about vacancies? It's a lot of Golang and not a lot of Ruby on Rails. And so, because I have experience in Golang, I want to tell you about Golang from Rubist. I have an experience in usage Go in a web, exactly in a microservices backend architecture, and also with some sort of calculations, because it's fast. In my opinion, entry level in Go is easy if you have experience in C-like languages. And it can be medium or even hard if you don't have. It depends on your experience in software engineering. So you can see some logos. It's a famous projects and companies that using Go and they like it. I hope you can recognize some of them. And before we start, I want to focus you about excluded temps. I'm not gonna talk about Golang speed. I'm not gonna tell you about BodyKit, databases, Kubernetes, load balancers, Nginx, application servers. You don't need this in Golang. And also about front end and security. So let's begin. How to declare variables in Go? You can use verbose notation. You can see it on the first row. It's an x int equals 42. So you need to declare type. And on the second line, you don't need to declare type. It's a shortcut, and on the compile time, compilator will choose type based on a value that will assign to y. And also I want to show you pointers. If you're familiar with C or C++, you know what pointer is, but if not, you can see at fourth line, there is a pointer and its value is a link to a x. So in last lines, you can see how to dereference this pointer to assign a new value to x through this pointer. It's useful when you need to manage some variables into a methods by link, and you don't need to copy value. Let's make a little stop on garbage collection about deallocations. In Golang, we also have garbage collector, and we don't need to manage memory manually. So there is one difference, one big difference between Ruby and Go. There is a type of garbage collection. In Golang, we are using generational garbage collector. The main idea of the generational garbage collector, it's generations. Every next generation of variables will live longer because the main idea is that long-lived variables will be lived more. Let's continue with syntax. Now you can see how functions can be defined in Golang. And I will focus you on a return type. It's a float 64 and an error. So in Golang, it's the most common case. You will return a result of functions, and also you have to return error, because raising exceptions, it's a huge operation, it's an expensive operation, and you don't have to do this, but you can. So let's say on the loops. Here we have some sort of for loops. First one, it's like for each, and maybe for in range too, like in Ruby. And second and third, it's one type. Third is a shortcut. We have only condition to break this loop. And on the second line, you can see verbose notation. So maybe if you're familiar with JavaScript or C, you can see that you could solve this. And on the right side, you can see matches in Ruby for each and for in, and also while. But match for the second line we don't have in Ruby. And what about lambdas? Golang have it, and you can see the example. And also same code on Ruby. And let's talk about error and flow management. In Golang we have keywords defer, panic, and recover. And its matches in Ruby, it's ensure, raise, and rescue. So let's focus on defer. You will frequently use this in Golang because Golang is a low-level language, and you need to close HTTP connection, you need to close files, you need to make something else a lot of times. And so when you want to do this, you just write defer and you write an action. And like in Ruby, you have panic and recover, like a raise and a rescue. But you don't have to use it frequently because you have tuples. You have tuples and you will return errors. You will not raise errors because it's faster. And let's talk about OOP. Here you can see principles. Here is 5. Sometimes you can see only 3, but it doesn't matter for current speech. But in Go, we don't have inheritance because Golang it's not common OOP language. And instead of inheritance, we will use composition. Let's see how objects, not objects, like classes, structs look like in Golang. Here you can see a person struct and the address, and it's nested in a person. And you can see fields that defined in a person and address, and the types of these fields, and some meta information. Here you can see meta for JSON. You can parse JSON with these fields into these structs. And also you can put it in JSON too. And let's talk more about inheritance. Here we have a common example of animal and dog. Animal is a basic struct. It have name and also it can speak. And dog, it have animal inside, and it also have name. And also dog can speak. Dog speaks woof. And here on the right side, you can see how to declare variables of the structs. So at the bottom, you can see how to declare dog. It should have animal inside with a name. And also you can call speak from it. Let's continue with composition or with overriding. Here you can see how to use super like in Ruby in Go. You just need to call speak from the animal, from the nested struct of this dog. And after it you can write your own code. But in Ruby you can just use super. Let's go to the databases, but I will not tell you about database choosing. I will tell you about how to go into databases. Here you can see some logos of ORMs that common used in Go. Let's focus on the most popular one, on GORM. Here you can see how to define struct of user model. You just need to put GORM model into the struct, and after it you need to define fields of this model. After this you can just call db after migrate. It's a magic method. It just updates schema of database, and when you first time created user, it will create table, and when you second time performing some changes, I don't know, maybe you will add address here, it will update table, maybe add some columns or change columns, but important point is to it will not perform delete operations. You can't remove email column, for example, by after migrate. You have to do this manually by SQL, or maybe you have to use migrator. And here you can see how we can implement migration for create users table in Active Record. Here you can see different type of selects and the differences between GORM and Active Record. The main difference is you have to call db-where or maybe db-find. It's GORM methods, and you have to provide link to the variable that will be filled by GORM. In opposite side, when you're using Active Record, it will return you new instances of these variables. So for the create, update, and delete, you have to do same things. You have to pass links to the variables, and GORM will do the stuff with these variables. And I want to focus you on preloads. GORM, like an Active Record, like another ORMs, have n+1 problem. And if you want to fix this, you have to use preloads or maybe joins. And here is an example how to preload some associations directly. And also you can use this example to preload all associations of users table. But in GORM we don't have some middle method of preloading associations like an Active Record. We can't provide it some schema to preload this. It will be useful maybe in the next updates we will have it. So you can see join here. It can get some clauses like where, and you can filter your nested associations. Here you can filter by payload. And also you can provide custom function for your associations. Here you can order your orders. And let's go to the web frameworks. Here you can see Jingoni, Goreval, Echo. Some of them is full stack frameworks. We will not talk about it. And we will focus on Jin because I used it, I know it, and I love it. And also it's most popular framework, or maybe almost. Here you can see example of a user struct updated for networking. You can go to the database to fetch it, and also you can parse it from JSON, and also you can put it in JSON. And here you can see a router example. You just need to define controllers and methods and routes. So there is easy to use, you can see. And let's focus on get user controller. It's look, I don't know, maybe horrible. It's too verbose, a lot of stuff doing here, but it's not hard. First of all, we need to parse param ID, and you can see tuple. It returns tuple ID and error. So next step, you will check on the errors. If we have errors, we will return badge request and some body with error. And if you don't have errors, we will fetch user by ID from database and return this user. Also, Go, Gene have middlewares. It have different type middlewares, global, per route, also per group. You can define a lot of middlewares, just put it in these methods. And that's it for the web frameworks. For the logging, I will not talk about it because it's a standard. Gophers uses standard ELK stack, and Rails coders use this too. But let's talk about testing. Here you can see GoDog. It's on the right side, like a hot dog. It's some Cucumber style BDD testing framework, like a Cucumber. And I think it's from Cucumber creators. But let's check Ginkgo. Here is an example of our get user controller, example of test of this controller. You can see how we can prepare a request on the first rows. Also you can see expects, and you can see familiar describe and neat like an expect to describe these tests. Let's continue with concurrency. You can see how easy it can be in Golang. You just use Go keyword, and then you need to print your function and call it. Here you can see Go print count. It will start another thread with this function print count. It will print some numbers 1, 2, 3, 4, 5 every second in a separate thread. And in the main thread, we will print main every second, and it will work concurrent. And very important thing, sync, is concurrency in web frameworks like Gene and Gorilla. As I know, is synchronous web frameworks. So by default, it will compute just one request per one time. So if you want to make them asynchronous, you need to use goroutines. It's like an example in the previous example. Here you can see updated controller function that uses anonymous function with a goroutine. So when requests come, it will call Go and go to another thread. What about communication between guardians? The most common thing you can use is channels. Here you can see how one guardian puts into channel message, hello from guardian, and in the main thread it reads from the channel. Important thing to know is main thread will stop while some message will not come to the channel, and after this it will print message. And maybe you ask, what about sidekick or some background jobs? Yes, we have factory. This is an instrument from Mike Perham, the creator of sidekick. But in my experience, I haven't seen any examples of using factory. Just because a lot of Gophers uses Kafka. They will just put some messages into Kafka and write consumers, and this will work like a background jobs. So let's summarize it. Golang is good, but not the best, because in this world we don't have best instruments. Also, in my opinion, Golang is too verbose and plain. But Golang is fast. And I think the reason why is there is not enough sweet. And so Ruby is not dead. Ruby develops, Ruby improves, and in my experience, last versions really improve the performance. And so Ruby is good. Don't throw it to the bin. Thank you for your attention. I hope it will be interesting and useful for you, and I hope it answered on some questions about Golang. And if you have another questions or comments, please feel free to ask me. Thank you again, and have a great day.
Alexander, welcome back from your recording, and I can say it's a pretty good amount of time has passed because your hair and your beard, they are back and glorious, and you look like a classic software developer right now, like a modern take of hipster software development. Still, we will talk about Go, which is for sure a hipster technology, very popular, very fast, intended for Docker and microservices, and so on and so on. But after Ruby, what are features you miss the most after switching to Go programming language? What Ruby features do you miss?
If we're talking only about Ruby, not Rails.
Yes. We will start with our programming languages, where syntax, semantic, toolchain, maybe community, and all the things we are surrounded with.
Yeah, I think it's first of all it's about sugar, but not exactly sugar. I think it's about functionality, about functional way of programming in Ruby. So you can use some. You can not multiply. You can take one array, take second array, write plus, and it will concat two arrays.
Yeah, that's great.
It's really great. Yes, you can simply push some elements to arrays, and a lot of stuff you can do easily. and also it's a dynamic type programming in Ruby, and sometimes in Golang you can miss this flexibility.
Yeah, for this particular talk, I need to change my appearance a bit. Let it be Ruby on the right, and yes, it sticks Golang to the left. The next question I want to discuss is contrary. What Golang features do you like, which are missed in Ruby or Ruby ecosystem?
I think it's not about Golang, but it's about philosophy of Golang.
Yep.
So Go is designed to be simple as a, I don't know, is a stick of tree, but Ruby it's a chainsaw. Um, and so in Golang, you should write simple code, and it will be sometimes more readable than Ruby code. Yeah, because it's not too much sweet in Golang, and not too much tools.
Yeah, the language simplicity is one of the strong selling points for the Golang programming language, and Ruby is often referred as never a second language. It's normally a professional tool used by developers who are already experienced and learn it because they want something from our Ruby world, like high salaries, creating features fast, and so on and so on. Still, let's switch back into the Go programming language. It is famous not only by as a very simple programming language, but it's also very well known for its quite unique approach to concurrency with famous Go routines and Go schedules with millions of Go routines scheduled across hundreds of threads, and everything just works with data structure and garbage collector, and just wow. With Ruby recently, we have these async fibers, so we can use some Go-like concurrency in Ruby. What do you think, comparing concurrent programming with Go and Ruby? Do you think Ruby now start to approach Go, or they are completely different, and I think fibers will never feel as great as Go routines?
Um, I think we shouldn't compare these tools like Goroutines and fibers. I think we should compare a way when we program some concurrent things in Golang, we should use Goroutines because it's almost a single tool. But in Ruby, a lot of examples in my experience, uh, my colleagues don't use any concurrency by their hands. They don't think about some thread safety between threads, thread safety structures, and other things because we have MRI interpreter, and it's logs here, and so when we run Rails application, Puma runs with the threads, and all this is thread safe. So
Yep.
I think if we writing some scripts, simple scripts in Ruby, it's more fitable, not more fitable, it's more looks like to Golang more than you. If you compare with the Rails, you don't need use to fibers.
Got it. And with a big project, Ruby is famous for the fact that Ruby developers can offer some really big software project, big in size of millions lines of code. And other Ruby developers who are Rails developers, they will come and feel themselves at home. Like we know how all this operates, we can start adding features in a few weeks and everything is great. With Go, development focus is targeted more toward microservices. But what about big project? If our team wants to create not a glorious monolith, but something big, if our microservice grows in size, can we still offer it in the Golang and keep this simplicity? Or millions of lines of source code will kill Go?
Second opinion. Millions of lines will kill Go. And when you're designing microservice architecture, you must make microservices. You shouldn't make from one microservice a big monolith. And it's because that language designed for fast, for simplicity, and it will be more spaghetti code, and I don't know, it will be hell.
Yep. Ruby and Go, they use completely different approach for error handling. With Go, we use this explicit notation with red, air, and explicitly handling result, while big Ruby projects, we use the famous dry library with dry monads for encapsulating all error control, for chaining objects, and basically it's all under the hood. We write only our golden path, and the errors are somewhere underneath and handled in some separate part of our application. So now you have experience with both approaches, both how Ruby handles errors and how Golang handles them. Can you compare them? Which approach do you like the most? What are some strong and weak points for them? Is it red air, or is it Ruby exceptions and dry monads?
For me, dry monads is the best. It's in my heart. But in Golang, when you use these tuples and you will broadly return arrow, it's in the first time it looks scary, but when you work with these projects a couple of weeks, you will skip these errors and only read the code. And modern IDEs will hide these errors for you. And yeah, and you know it's a banner. I forgot banner blindness. Banner blindness.
Yeah, that's a great approach for modern IDEs to modify how our code looks visually. I first saw this many years ago when closures were added to Java, but they were like anonymous classes, and you need to write lots and lots of code to use some lambdas, anonymous functions. But suddenly, modern IDEs they collapse everything into familiar Java equal more sign, and that was great. And after this initial approach many years ago, I see it more and more where IDEs they collapse some syntax constructs into easily to recognize things in our source code, so we do not need to boil our brains while reading for thousands red air fields of text. Still, Go has a reputation of pretty simple and straightforward language with no syntax sugar and with sometimes lots of code to write. Is it bothering you that you don't have all the shortcuts and pleasant syntax things at your disposal, that your tool, your instrument is crude, like an mighty but ancient stone hammer?
I think it will come with some experience. After a few months, you will like it. But first time after Ruby, you will spit on Go. And but now I'm looking to go. I don't know. It's really simple. But if you wrote a nice code in Go, it will be nice looking, and you will read it easily. But and for the sugar, about the sugar, in Ruby you can take first elements from array by I don't know 100 ways. But in
Dot
Golang,
first is really amazing. I miss it in Python.
yes, dot first it's really amazing. And second, but you have take method, drop method, and another ones. But in Golang, you should address to the index of array and take it by hand. So you don't have I don't know what is word.
To think, to choose, to make some decisions. It's like obvious in Go. Only
Yeah,
one way.
only one way, and you don't need to make some decisions, and you don't need to Google what this method do. Uh, like a few days ago, I first time saw drop method, and it's just alias to take method. Yeah, in Golang you don't see this.
Lots of aliases. It's like in Python. With the Python programming language, we have this Zen of Python, the one of the, how to say it, guiding principles is there should be one and preferably one simple way to do something. Simple and obvious way to do something. Okay, thank you a lot. Please join our next meetups as a guest. And if you want to tell us more stories about Ruby, about Go, about other programming languages, and how Rubyists look on them, please click on the meetups.singula.team, apply the talk button, and come again.
Thank you.
This concludes our session. Please like, subscribe, follow, and see you on our future meetups. Remember, if you want to have a talk on one of our meetups, please go to meetups.singula.team, click on the propose talk button. We will communicate with each other and arrange your talk in this virtual studio. My name is Gregory. It was Singula Team Online Ruby Meetup. See you later.